So you just go to the pile of E1, pull an E1 piece, put it on there. You go to the pile of E6, you pull an E6 panel. Like I said, it's an IKEA simplistic manual putting it together. Now these guys, once you guys go to South Africa and see how it's done, once we train a crew, they use the manual for the first 4 or 5 houses. By house 6, it's boom, 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 boom. There's no having to do that. They just know what's coming next and they just do it. So that's where the speed comes in. Next slide, please. Now we're getting around. So again, this builder here wanted to use the wood trusses. Again, whatever the end user wants, we will comply with. But it's kind of neat to show we can interchange our product and do it different ways. But at the end of the day, I still recommend the metal trusses. We used to weld our metal trusses. We now bolt them. 2 things why we did that. Number 1 reason was welding takes a set skill to be a welder. Average age of a welder in America now, I think, is 55 years of age. So going to the bolt system, and actually Clint was one of the guys who helped design this. It actually is sturdier, stronger, and as we all know, anyone can put a bolt in a washer and bang and tighten it. Well, that's why you have inspectors. That's why you have inspectors and you have a crew. But the point is, you've taken out a skilled task and made it an unskilled task. Was why I do this, to make a simple process. Here you can see the corner piece. So everywhere where you see corners, that's what the corner piece looks like. So it's got basically it turns so the panels can fit each way. One drawback to our product as of now is curves. Most of our stuff are very square. So like as we came in, all those houses you saw, which is still, we can do those external elevations. Very simple. You start getting into the round rotundas, like on higher end custom made homes, we have some challenges doing that. Now we can do that, but we end up having to use wood for the round rotunda to fill in the gaps. Just like the same way that they do their round rotundas, where they put the wood in there, we do the same thing, except with a 2x4 you have a panel. That's the difference. So again, that's why we don't want to be a custom home builder, we want to be a volume home builder. Next slide, please. All right, so over here you can kind of see where the power system, the HVACs are going to go, all that kind of stuff going in. You're starting to see some design going in, and you'll see how that the roof was designed and give you some of that external elevation changes and whatnot. Here's a good shot of the panel, and you can see the honeycomb system. So as we start talking electrical and plumbing, you'll see where that's going to drop in and how that's worked. Or it's done at the factory, either or. I'll show you that in a different presentation. Next slide. Just more of the same picture. I'm going to kind of just click through these because we try to show it as the stage is being built. So in this picture here, what you see, now you're starting to see the bedrooms popping in. All these holes you see, 2 ways that's done. We do it at the factory or we do it on site. With the circular saw or with your drill, you simply take off the drill bit and you put on the little cut system and just pop a hole in there. That's all you have to do. So this is where your gas lines, your electrical, all those are going to come through after they get dropped down. So now you can see what that is. We prefer on an assembly line system on site that this get cut on site, not at the factory, because there's too many things that just between what the guy did at the factory, when you're clicking it all together, it's completely different than you just never have to do the Kentucky windage type thing out here sometimes when you're doing it on site.
Now to get a specific panel.
So that process to cut those holes, process to cut those holes is part of your timeline that you've already calculated.
So to cut all of that is about 15 minutes. One person, 15 minutes of work. That's all it is.
Wow.
Now remember, to go line your electrical wire from that part of the house all the way back up, how long did it take a drill or to staple that all the way through every single 2x4? So you have
to probably also do that after your sheet rods.
Yeah, you can do it either way.
Speed up the process even more. Right?
Next slide. All right, so again, now you're seeing the garage come together. You're starting to see some electrical wire, which is really what I started getting to. Next slide. So now we're hooking up the gutters and all that kind of stuff, and that's the metal stuff. So again, I don't agree with that, but again, what the end user wants, if you tell me you're going to want wood trusses, we're going to do wood trusses. But again, we want the product, especially in a flood area, use the metal trusses, because the whole purpose of that is wind resistant, waterproof, mold proof. That's why we want to do that. Next slide. All right, and next slide. We'll get to that. So here's a good picture again. You can see the quarter piece, you can see the headers and the footers, and you can see the actual 8-foot panels all there. And that's the purpose of that.
Are the interior panels the same architecture as the exterior?
There is no interior exterior. It's all the same panel.
That's all the same panel.
Exactly.
That must be really soundproof too.
Oh, it is.
That's great.
Yeah, so I have all the decibel stuff and all that. So like I said, this thing was built, so we also can, not that anyone would want to do this, we can armor this. We have a thing with
I know people that would.
Wait, so we have a company called Buffalo Armory up in New York. They did an induction heating, and you know General Batiste. They get quarter-inch steel, put it through. If it's not a 30-06 armor piercing.
And we're in Puerto Rico.
Wow,
Yeah.
So, and there's no on the back side. I mean, I wouldn't want to be on the receiving end of that thing, but there's nothing on the back. It'll still knock you on your butt, probably crack a few ribs, but you live. So,
How many days is this so far?
this is all the same day.
The same day?
Yeah. This entire house was built turnkey from the foundation up 7 days.
Wow.
Okay. So next slide. But this is where the train cruise is critical. So that's why on this one. So they laid all the insulation. Now they're going to put they're laying the actual metal roof on top of that. Next slide. All right. So gas, plumbing, electrical. So that's washer, dryer. There's your stove. And they do things differently over there. Again, remember, we will do everything to whatever market we're in. And then there's your electrical. And that's how it comes down. You can just see how it's all run through the ceiling and just drop down.
And then Mike, go back and touch base on the roof system as well.
Okay.
You know, it could be composite or it could be.
Yeah, so we could do shingle, metal, concrete. Obviously, if you want all the benefits, we prefer metal. But our solar panel system, if they want to incorporate that into it, it's good for anyone except for the concrete tile thing. On that one, we actually have to put bolts into that, and it sits up off the concrete tile. The rest of it's kind of built into the roof, so it's kind of neat how that works.
So this is where we will have insulation.
Correct. Yeah.
Because of the heat factor from that metal. Is that being tested yet in terms of this climate yet?
Oh yeah, I mean metal roofs. Yeah, I mean that, and this has a 50-year lifespan too. So shingles is what 10 years on.
I'm talking about the intensity of the heat.
Oh yeah. I mean
inside the attic.
Yeah, we would use the same. Every metal roof that's done in Texas right now, it's the same material. There's no difference in the two materials. So if you bought a metal roof, go over here and buy a metal roof right now and put it in place. That's the same metal roof we're going to.
But have you tested it for the heat?
It's,
I'm just talking about in terms of the energy issues and the consumption of heat resistant. Now we could put something on the inside of that attic.
Metal's better on heat resistance, I believe. For shingles for
Okay.
energy efficiency, basically.
Okay.
What he's asking.
What's the center on the trusses on the metal? How many foot centers on?
We 2 foot, 16 inches.
2 foot or 16.
what did we do? I think we did 16. Yeah, we
We're
did
doing
16.
16.
But again, what is the
Well, because depending on,
exactly.
prefab trusses are typically 2 foot center.
So-
But, I mean, so you could get by with 2 foot centers, I would think, with that. But
Well, we did the 16 because we were going to do the 2 foot, but we did a 16 because the amount of trusses that was sent to us.
yeah, well,
So
16
we
better,
couldn't go
but I
make
think
some more.
2 foot, you could probably get mine of it.
Right.
And this is an Australia bill, right?
Yes.
This is in Australia, so it's
How
kind
much?
of.
How much more would it be to put that composite panel on that roof as far as weight?
Oh, yeah, you wouldn't want to do that.
Okay.
Like I said, the structure we're going to go see is 350 square feet and it weighs 26,000 pounds.
How do you move
I think
that?
you said each one of the panels weighs 100 pounds or something.
Yeah, 95 to 110. So
When you do a 2-story, they put that panel from the subfloor.
yeah, so it's got 26,000 pounds per square inch pressure going down. I'll show you that stuff in the test on that. They put that in and it didn't break. So,
Drive a truck.
yeah.
Yeah, that's not
I mean, you put dirt, rebar, concrete inside of that stuff, and you built a fob. I mean, remember, this was all designed for military applications. It was dumb luck. Rather be lucky than good. It was dumb luck that we just, after all the testing was done, it was determined we had a better permanent solution than the temporary solution that we were actually trying to
For
work.
a better timeline too.
Yeah.
So are y'all
Because the speed of this was going into a combat zone, setting this up, or building a forward operating base or command outpost, forward operating areas and stuff like that. That's what it was all designed for. Or disaster relief, and people still could be living in austere environments because of all the other stuff, the debris around, all that protecting people. So,
What's at $43 a square foot? That doesn't include all the other finishes and so what exactly is that $43?
so $43 a square foot is the entire build out minus the
It's a
finishes.
shell.
But it includes the
Yeah,
drywall, includes the external cladding. The issue though is I can't give you a quote on the internal stuff because we can go very low end carpet to hardwood floors.
To concrete,
Yeah.
concrete floors.
It does not include labor, that's just materials.
It does include some of the labor, so it doesn't include your portion of it. It includes our portion.
So the foundation numbers in there too.
That gets up there.
The
Foundations is normally $10 here in Texas to $12 a square foot. That's why we prefer to do our helical system. It's a lot less expensive, and it's actually a better end state by you don't have foundation issues
because we need to be 2 feet off the ground.
Yeah.
What is that foundation made out of?
Screws, big metal screws. I mean, I'm not exaggerating. Things about this big, about that thick, and you put 100 of them in on a 1,200 square foot house, and it's sitting up off the ground.
You need 2 feet.
No Portland cement or concrete used. That's really interesting. I'm doing some studies right now on carbon emissions, and Portland emits for 100 years.
Yeah. Well, the other issue with that too is when your foundation fails here, you got to go have someone. They got to crank it. It costs money. You do this. You call us. We go out there. A guy goes, measures it, and he goes to one thing, goes, and he's done and walks away.
Mm.
So that's all it is.
So is there an option for the type of foundation? Can I do a crawl?
You can do anything you want. So the reason I'm showing this is just because everybody knows the concrete foundation. If I started off with a screw helical system, 90% of the people are going to look at me not knowing what it is, and then you're going too far.
It's called a screw.
It's a helical is what it's called. But if you just Google screw system helical, either way, I think it's Helical. But don't quote me on that.
They are used to level foundations currently.
Right.
When their house is level.
So when a foundation fails, that's what they use to fix it. So why not just start with that and never have a failed foundation? And then you don't have all the other problems, and it's less expensive.
So you're basically what you are is $100 a foot finished turnkey out the door, which is the cheapest thing you can put on the street.
Now at $100, we're with some higher end.
We need to be closer to $70 for affordable in Texas.
Right.
Soup to nuts, because your finishes are going to get you there. You know. But the bottom line, I think we need 2 feet, and that screw system is for our gumbo soil, man. That is what we got to have anyway. Right. Everything else has just been stuck on
soil
stupid.
Composition dictates if you do concrete, pier beam, helical, whatever system you're going to use. That soil composition test.
Option too.
What's your footprint? Can you go to Oklahoma City with this?
Well, we've built right now in 63 different countries in any climate, from snow to desert to swamp. So we can build anywhere. There's no limitation on it. Yeah.
You got a challenge in Alabama, huh?
Nobody really wants green buildings in Alabama.
Oh no, we got 600 acres ready to go in Alabama. We ready to roll. We ready to roll right now.
You got water now?
Yeah, man.
We got our sight set on Alabama.
Now Nashville is actually going to partner with Alabama, which is what this conversation is about right now. They got 500 acres. They're going to see in a little bit. Hardy, you there?
Yeah, I'm here.
Okay, we got 500 acres in Nashville. We're going to see.
Not Nashville. Is it Nashville?
Yeah, it's Nashville.
Gsxi, website. Daryl James is a site engineer and site economic developer, site search consultant. He and I have worked together for decades, and but it's very premature to know that that's exactly what we're going to do. But we're going to talk about that later today as a potential.
Yeah, we're going to partner with Alabama Project with that Nashville group.
And so, Hardy, that's in you said that's in Dixon, Tennessee?
In Dixon.
Exterior of the house, as you can see, as it comes out of the concrete and all that kind of stuff, you're going to put the HVACs, no change to how that's done. Next slide. Next slide. And next slide, you're starting to see the shape of the roof a little bit coming into play now. Next slide. Some of those pictures are out of it. Exterior of a house, you've seen this before, but imagine it with 2x4s, now you're seeing it all coming through the walls and stuff. We have a foam system that we spray in there, again, with all the environmental friendly stuff and all that kind of thing as insulation. Next slide. Getting ready, that's actually the kitchen counter. It's going to go in there. Next slide. All right, so here's some of the finishes. And again, don't get what you see here. It's not something we might put in a U.S. home. But the point of it is that the finishes, and again, if you go to any Australian home, they all have the drains in the middle of their floors. So that's just the way they do it over there. So we wouldn't do that design here. Next slide. There's the kitchen. Want to show you something here. You can see the crown molding baseboards, all that sort of stuff, that's all made out of fly ash. So that's why I say when you get inside and the thing is done, the house, now all your furniture would be ruined. If you had sofas and everything in that house flooded, it would be ruined. You're gonna throw it away. But after that, you can go to a bottle of bleach, wipe everything else down, and move back into it the next day.
Wow.
So you have no structural damage to the house. If for some weird reason water got this an interior wall, water got underneath it there and got into the panel and stuff, the panel cannot mold. So the water will eventually over time evaporate and the house can still be lived in without having any mold issues ever pop up.
You're building the cabinetry as well?
Yep, all that comes in it. It's a house and a
fire?
fire.
What about fire?
Fire is a little bit different. Now the fire, all of the Polex board you see here on the walls would be destroyed. It's going to burn through that. The tile, because again, that's not made out of our material, that would be destroyed. But you could literally go in there, scrape it out. All the panel would still be good, and from the panel forward, rebuild. But going from the panel forward versus to basically a foundation forward, that's how much time you're saving.
And I can finish that kitchen out any kind of way. I could have granite.
Anything you want, yeah. I mean, again, whatever the local aesthetic style is. Next slide, I think there's a best known slide.
On that interior trim, Mike, is it brad nailed and glued, or how you doing with the
screwed?
Screwed
and cocked. Everything's a screw.
What about the air exchange?
The HVAC?
Air quality, is that?
Well, again, in R16 and R18, you put the HVAC in, it's no different than the house you're living in right now. Your house